Yeah, hi, my name is Tomasz. I've been here a couple of times already, so you might remember me or not. All of the slides for this talk are at my website, tomasz.eu, which is actually a bit significant on the topic of this talk. So yeah, I want to talk about Homelab networking mostly in 2024 because there has been a big change in the recent years in how internet works for each one of us, even though you might not have felt it actually. But the change is there, and like it's been pretty deep and it's pretty blocking if you want to do home labbing now. But fortunately, of course, there are tools making it better, and this talk will be focused on those tools. If you have a short attention span, only if you need to, I don't know, like go away or go into your phone or break the stock, or I don't know, connection breaks if you're watching it or something, this is going to be mostly about two tools, Tailscale and Cloud4 Tunnels, that enable us to self-host with today's limitations. And yeah, let's talk about those limitations. But first, what is a home lab? It's a pretty fancy name, although if you break it down, it gets easier. Laboratory is basically a place where you can like safely conduct experiments. So, you know, we are in IT fields, we are not allowed to experiment in production environments, at least I hope you are not allowed to. So for us, a lab or laboratory is a place where you can safely experiment with environment for our or any other different applications. And Homelab is basically this, is having such a space for experimenting with deploying applications and running applications in our home. So I'm going to also use it interchangeably with the word home server, which is a bit closer to what it actually means. The difference is that Homelab can be a bunch of home servers. You can set up a whole cluster, a whole ecosystem to mimic your production environment or not. Home labs are popular nowadays because of well, frankly, because of like how cheap and how easy it is to now run a home lab. Like you can get a computer that's able to run some applications for like absolute pennies. And also a lot of people have realized that they already have such a computer bought and running in the form of their network attached storage. Like they bought a Synology to store their photos or something, and they realized that, hey, that's actually a pretty competent Linux environment. And there's Docker giving me good isolation. I can basically run applications of it. And also because this hardware not only became cheap, but also became smaller and smaller and quieter and more convenient, so that you can hide it next to the router and the rest of the people at your home don't even know that you are running a home lab. So yeah, it's very easy to run a home lab, very convenient actually. If you, for example, take like a mini PC, for example, even like a Mac Mini or any of the other things that are now like hosting stuff, like you can get like a pretty competent Intel N100 with everything for like 600 zlotys or something. And it's a pretty competent 4-core machine, like, you know, passively cooled, 6-watt TDP. You won't even see it on your electricity bill, and you can run a lot of stuff of it. A lot of people, again, begin their home lab adventure, and so did I, with running stuff off their network attached storage that's primarily used for other purpose. But come on, there's like a 4-core CPU that's just idling. Why not use it for something? Why not have some fun? And also a lot of people are realizing that this Raspberry Pi that they bought some time ago and is lying somewhere in the drawer, it can actually be like used for hosting and running something. Although, in my opinion, like I own every generation of Raspberry Pi in every variant, so I'm a huge fan. But I personally think it's actually pretty bad hardware to do a home lab, because like it's pretty inconvenient. You need to have like an enclosure, the cables stick out of like all the sides, and but if it's the only thing that you have, it's basically free or already paid for. This is the way to try it. So yeah, why run a home lab? Well, you know, because we can, because it's fun. Because a lot of people realize that cloud services are great, and you should totally use cloud services for backing up your data and photos and email and stuff. But it shouldn't be your only place with such data, because it can be hacked into and then it can be wiped out. You can lose your account because some weird algorithm decides that you have broken the terms of service, and before you get into like an actual human level of support, your data will be wiped out of oblivion, or you'll be running through 2 months without your important photos or something. So it's a good idea to basically own your data and host some of your data. And also a lot of those tools enable you to build like some integrations that are pretty hard or impossible with third-party or cloud-hosted stuff. There is a whole list created on GitHub called Awesome Self-Hosted. So if you just like Google awesome-self-hosted, you'll run it. And there are like categories of stuff that you can self-host. And most of this stuff is actually very easy to deploy because most of this stuff, it's 2024. Most of this stuff comes with like a ready-to-go Docker image or like a ready-to-go Docker Compose YAML that you just run and it just goes. So what's stopping us from just finding an application, like for example, I don't know, like a pretty decent photo application / server that is on par in terms of functionality or something is better than Google Photos is, for example, Imich. What's stopping us from, running Imich? Well, because A, the setup is complicated, but okay, now Docker handles it. But also B, it's kind of complicated to access it from the outside. Like it's pretty useless or not as useful if you can only access your application when you're at your home because, well, that's not the point, right? The point is to be able to access it when we are outside of home. And this is where the networking stuff comes in. And in the past, when we were running such stuff in the, at home, using our home internet connection, we usually got like a dynamic but public IPv4. So it was a matter of finding it for the first time, configuring one of the dynamic DNS services. So getting a domain like, I don't know, so like Tomasz's home, duck.dns.org, and setting up a script that will just ping duck.dns that, hey, are you sure this is my current IP address? If not, refresh it. And then we got like a direct access to our home router, and it was only then a matter of forwarding some ports to our server. If we wanted to act as if we were inside our home network, we would run a VPN service like WireGuard or something. It wasn't the easiest thing to do. It wasn't something for every like casual computer user to do. So some tools have been created to actually mitigate it and make it easier, but it was predictable and doable. But you might be one of the few lucky people who still have this possibility of public dynamic IP, but there's a pretty big chance that you no longer have such an opportunity because what happened in the last few years is that the pool of IPv4 addresses, the public IPv4 addresses, this pool has dried up a couple of years ago. No IPv4 addresses could be assigned or given or sold to anyone. Basically, everybody who got their hands on public IPv4 addresses kept them, and they are now selling them at a premium or not selling them at all. And which means that the internet providers that probably either includes or is going to include the one you have at your home, they can no longer assign a public IPv4 address, even a dynamic one, to each of their clients. Their pool is too small. So what happens is something called CGNAT has been deployed. It's called carrier grade NAT, and it basically means the same as if you're in a corporate environment. Basically, you think that you are autonomous at home, but actually you don't have a public IPv4 address. You have an address that's like your home router does have an address that is behind the net of your entire carrier, and the edge router actually going out to the actual internet with public IPv4 address is one step further at your ISP. And if you want a public IPv4 address, you either can't or you have to pay extra because it usually comes with the enterprise service of having a static IPv4 and so on and so on. And also then if you change operators or change homes, you still have the same set of problems. So there's CGNAT, and like we can say that it sucks, but it's like the reality we are at, and we have to work with it. So how do we deal with a situation when we no longer have a public IPv4 address and there's like no straightforward way to access our home server that's within our home from outside of the internet, especially when we are using, for example, like a network at work or corporate network, which also puts us behind the net. Then we have like a double net environment. And everybody who studied computer networks knows that it's impossible to establish a connection between two nodes behind the net, behind different nets, because there's like TCP/IP won't allow it. You have to have one of them has to establish connection having some sort of like public handle to the other. So what happens is that you can probably set up your own proxy server like buy a VPN and pay through your nose again for like yet another service. But that's not the way to go. And there are services that have like way more features beyond that, but they market some of the subsets of their features for free to people running Homelabs because it brings them actually like a lot of commercial traffic afterwards. So instead of running WireGuard, for which you would need like a reachable IP that you no longer have with CGNet, there is Tailscale. It's actually based on WireGuard, and there's like a lot of open source in Tailscale, and a lot of their stack is released as open source as well. But basically what happens is that you install Tailscale on the devices that you want to, that won't have as nodes, because we no longer have a client and server. They're all like nodes in whatever network they can be at. You can install it on your phone, on your laptop, or like using computer. You can install it on your server, and Tailscale basically almost transparently sets up like a virtual network, and all your nodes are within the same virtual network. Only you can access them, or people that you add to your Tailscale account. And it's great. And it basically means that, like it's a matter of running up sudo tailscale up, and then I'm in my Tailscale virtual network, and now I can go to for example, as you can see, I have a couple of devices running. Those are like at 3 different locations actually. So for example, I can access my Synology NAS from whatever network I'm here at. I don't know if it's going to load here. Yeah, it does. So yeah, this is my Synology panel. So I can basically fire up Tailscale, and I can access all of the files that I have on my Synology wherever I am, from the phone or from network, and you can too. And it's great if you have a limited set of users, but a lot of access that they need. So basically you and maybe people from your home, from your family, who need to access, for example, the same Synology drive, or the same services that are like your private for family, I don't know, like shared calendar or anything like this. But what happens if you want to have like your typical way of hosting applications? For example, you've built a website or an application or something for a wider audience. You still run it in your Homelab because, for example, it's using your, I don't know, it's using an LLM, and you've deployed Llama by yourself, and you don't want to pay through the nose for a GPU in the data center because you already have a GPU at home. Hey, mom, we have GPU at home, right? And you can use it. It's just that you need a way to access it, and the way to access it is to be at your home. So what happens if you want to host something to the outside world? There's another service. There's Cloudflare Tunnel, which requires you to own a domain, and that's basically it. And if you own a domain, you fire up Cloudflare Tunnel daemon on whichever server you want to run it on, and the daemon will take care of establishing connection with Cloudflare, with your account on Cloudflare, and basically opening a tunnel that traverses NATs, well, because it's like from domain, then Cloudflare, then to your machine, regardless of like how many nets are there on the way. And it's pretty straightforward. Like you don't need to have any network knowledge about it. You just go to your Cloudflare. Yeah, the dashboard is temporarily not available, but yeah, it's going to take me a second. Sorry. At least I won't have the embarrassing experience of doing a reCAPTCHA in front of the audience, which I often fail. So I'm not human when I'm presenting. So yeah, for example, I have like 2 such tunnels. One is basically one that I had set up to my home, which is at the Sienkiewicza Street in whichever town. And the other is actually to my laptop. So I can fire up a Cloudflare tunnel also on my laptop. And the best thing about it is that when the tunnel is running, Cloudflare or nobody cares physically in which network it is, as long as you can connect outside to the internet. So I can I can spin up a service on my laptop or a mini PC or a Synology. I can take it with me to, I don't know, 1,000 kilometers from here to a different country, connect to the internet, whichever service there is, or through a mobile network, fire up the Cloudflare tunnel again, and it would still go, and it's still going to work with the same domain transparently to the users of my page. And for example, the tunnel that's here, that's like considered healthy, is basically a tunnel to my, the website that's on the slides. It's like a very stubby website that I've put because I needed something for the 13 gigabytes of archive of my funny images that I've been collecting throughout like something like 12 years on the soup.io service. So I have them archived at soup.io, and this is still running from like a Atomic Pi single board computer in the bedroom somewhere. So yeah, so basically because there's like 13 gigabytes behind this soup.io, which is like the same machine, you can very easily DDoS my home network if you want to. Like like you can totally fill up my entire upload chunk, which is like 1/10 of my download. So please don't do it. Fortunately, my home site where the talk actually is actually on a VPS. Although I might self-host it again. So yeah, so those are basically two services that offer us free, both in terms of money, but also in terms of amount of time that it takes to set up something working. If you've ever set up like an IP tables reverse proxy, you probably know what I'm talking about. Those are two like very simple to use things that basically put the barrier of running a Homelab or hosting something in a Homelab and using it from outside pretty low. Yeah, I'm not going to like do like a little demo, but also if you're like an advanced player, you've been around there a while, you know what IP tables is, or you know what Nginx Proxy Manager is, and you just love setting this stuff yourself, and also you love paying for a VPS. You can basically have a public machine to proxy your traffic through that you can buy, or maybe you can even get one for free. I think Oracle Cloud, if you're not scared of giving anything of your stuff to Oracle, I think Oracle Cloud offers you like a free VPS. That's just basically enough to open like a proxy service that can tunnel your traffic through. Those have, and there are like tools already, like Rathole or FRP, that make it even easier. Like you don't have to set up everything manually. Also, if you set up everything manually, it's going to route all the traffic through the VPS, but if you're going to use like one of those tools, and also there's like a lot of other tunneling software, they are going just as tailscale, doing something called NAT traversal, which basically means that this public server is only used to establish the connection between the two nodes, clients, machines, one being your home server and the other being, I don't know, a phone of someone accessing it. But as soon as it's established, it's going to switch to a direct connection that's no longer going through your server, which saves a lot of bandwidth, right? That you might have to pay for. So again, there are some links, and there are like a lot of those things at Awesome Tunneling project on GitHub at Anders Pittman. Yeah, but again, this is if you're an advanced player, and my recommendation is, because like I know how to do it, and I tell you don't do it if you don't really have to. Like like it's a lot of work, and it's pretty inconvenient. Sure, you get to control everything and every step of the way. It's just that you don't always have to do your own plumbing. Like sometimes if someone offers you to do it for free, you should just accept the free stuff. And yeah, that's all. Thank you. Yes, Chris.
All right, so I've kind of dabbled into this some time ago, and there is a very specific rule in my internet service provider that says no servers whatsoever, and they are actively monitoring for it. Have you stumbled upon this?
I haven't, and I have no idea how they could enforce it, because when you're running WireGuard, which includes Tailscale, the entire tunnel is basically encrypted. So like I see no way for them to monitor it, as long as your server is not like very noisy in terms of like sending outbound connections. So I haven't I haven't even read into it, frankly.
I kind of thought that they are basically monitoring if the upload and the number of connections externally goes up significantly. They will suspect that it's a server, but it's very difficult to tell.
Yeah, it's difficult to tell, and also like if I'm accessing my Synology from my phone, when I'm outside of my home and I need to access my Synology, you could argue that it's a server, but at the same time, if my ISP then told me that I broke their TOS and they're going to block the service, I would tell them to go fuck themselves, frankly, because it's okay, formally speaking, it's a server, but also it's a way for me to use my connection to access my data that I own, and I need to be able to access it, right? So I haven't seen anything like this in terms of service that I've encountered. But it's maybe a good point to look out for stuff like this, because that could be a limiting factor. Yeah.
I'm also very interested how TOS defines server in your.
Yeah. Then again, right? Like like how do they want to monitor it and how do they want to determine it? Like it's.
I kind of suspect that what they mean is a website that is basically accessible through a domain that points to a computer located in the network. But that's just my suspicion. Like when I was reading through the TOS.
Right, but this definition is fulfilled by your home router.
Yeah, that's true.
Yes, there was another question.
Yeah, have you used zero tier instead of Tailscale? Have you tried both?
Zero G?
Zero tier.
Oh, zero tier. I know about it, but I haven't tried it.
Okay.
And it's also one of the things listed at the awesome tunneling tools. So it's listed. Yep. Any more questions? I think everybody's like longing for the barbecue, right?
Any security issues? You basically allow people to come to your home.
If you expose a Cloudflare tunnel, yes. But the thing about Cloudflare tunnel is that you expose. Oh yes, I can show the configuration finally. In the Cloudflare tunnel, like because in Tailscale, Tailscale is sort of like a limited amount of clients or people allowed to use it because you have to add them to your Tailscale account, they need to authorize and so on and so on. But a very broad access to your virtual network, even though you can fine tune it, but regardless. Cloudflare tunnel is kind of like the opposite. Cloudflare tunnel is like make it public, but a single port or a single address in your home network. This is, for example, the only thing that Tomasz.eu is pointing to within my home network. So yes, there is a domain that allows people in, but again, this is only to the machine that has the Cloudflare tunnel running, and this is only to this specific port and IP. So on this machine, and even if you hack this specific machine, it has, for example, no access to my Synology unless you break into like SSH and then be in a virtual network, right? And then there's only like the password protection. Yeah, for example, this machine like has no significant data for me. Like even if you crack it, you can wipe it, and I won't care at all.
Have you heard? Thank you. It was like saying that it's only one port kind of solves it probably because you have like limited possibilities.
But you can also.
But have you heard about any exploits like at any level of this software being developed? Like were there any exploits in the past?
Not at this layer. I've heard exploits in software that people self-host, so at the lower layer, but I haven't heard about exploits in Cloudflare tunnels and in Tailscale. Again, like Tailscale is built on a pretty trusted, pretty well tested software called WireGuard. And in Cloudflare, you can also like limit access further. Like you can actually make the domain available onto people who will authorize with Cloudflare again, and only they can access your domain. It's a bit lighter than the Tailscale stuff. Tailscale needs you to run like an entire service and so on. Cloudflare will just put like an extra login layer on top of your domain, on top of your service. But no, I haven't heard about any exploits in those two services.
Right. Thank you.
Do you have some suggestions or ideas about the hardware that we could just have it running at home? Because actually I do have a Raspberry Pi, which I use as a RetroPie for like old-fashioned game playing. Also, I do have some QNAP, which is, as you have mentioned, is not enough horsepower to host all of Dockerized stuff. So something like powerful enough and like possibly calling.
Yeah. So, in my opinion, the best bang for buck is. Those are expensive as hell. But so okay, it's like let's click this on low. It's too expensive. Like buy it straight from China. Anyway, I think the best bang for buck. You can buy them for like something like 600, 700 zlotys. Is an Intel N100. Like, of course, without Windows because it already ups the price and so on and so on. But like Intel N100 is like very low power, so it's always passively cooled, and you can put like an actual real SSD into it, so you can run like a Rails application with solid cache and solid queue and test DHH's claims that you can have like a very good cache speed with solid cache. And basically, yeah, if you find like a version without without Windows, you can buy it for something like 600 zlotys. And in terms of stuff to run, any of the applications, this one is like way over almost anyone's needs. But frankly, if you own like a NAS, like a Synology or QNAP or Asus or any other product like this, I would suggest just running a couple of Docker containers there, because usually the CPU is powerful enough, and usually, you know, if you have a NAS already, you've already paid for it, so you don't need to have like any extra costs. And also, NAS is designed to be like plugged and turned on 24/7, right? So,
unfortunately, mine is not powerful enough, so you know.
Okay.
I just put too many stuff there, so I am looking for something.
Okay, yeah, maybe then get like an Intel N100 or N200, and it's really more than enough. It's like, but also, like, you know, if, for example, if you're budget constrained, you can also find like so-called like thin clients, or like, you know, like some older mini PCs with like some older generation, like, you know, but still pretty capable, you know, CPUs for like 200, 300 zlotys, like some like, it was called like, I think like HP Desk Mini, or like Lenovo Mini something, and there are a lot of those machines on eBay, on Allegro, like on like every site that sells used computers.